Hey, did you hear that? It's quiet in here. Must be ready to do another video. This time, topic is slopes, as you can see. So I've got 4 points here that I'm going to plot, and we'll connect, and we'll see what happens. So point A is at -1, -3. Point B is at 3, 3. All right. Point C is at 3, -2. And point D is at -3, 2. Okay? I'm going to attempt to connect a couple of these points. Let me go back and let me label which ones are which. This was A, that was B, C, and D. I'm going to connect A to B so that we're good there. So point A to point B. I'm going to connect point C to point D. And hopefully you're noticing something right now. You're saying, that's interesting. What do you notice about the relationship between those two lines? What are you thinking? That's right. They are perpendicular. Okay, perpendicular lines right there. So these two line segments are perpendicular to each other. That means they form a right angle. It means 90, 90, 90, 90, 90, 90 all the way through. Okay, so without looking at the picture, how could we figure out that those two lines were perpendicular? So since I talked about slopes at the very beginning, obviously it has something to do with slopes. So remember the slope formula. Slope, y2 minus y1 over x2 minus x1. So, if we go through the story, x1, y1, x2, y2, we plug in what we know. y2 is 3, y1 is -3, 3 minus -3 over 3 minus -1. Top I get 6, bottom I get 4. That simplifies to 3/2. So that's the slope of AB. Let's do the same thing for CD and see if we notice a pattern. Okay, so for CD, 2 minus -2, that's my y coordinates, and my x coordinates, -3 minus 3 more. 2 minus -2 is 4. -3 minus 3 is -6. So that reduces down to -2/3. Do you notice something about these two numbers, these two slopes? What do you notice? Notice they have the same numbers, okay? And what do you notice about the numbers? That's right, they're upside down. And the other thing we would notice is that one of them is positive and the other one's negative. Okay, so typically what we talk about when we talk about the slopes of perpendicular lines, the slopes of perpendicular lines are opposite reciprocals. Slopes of perpendicular lines are opposite reciprocals. Okay, so opposite means one positive, one negative. Reciprocals means flip them over. Flip numerator. That's probably, let's use some real math words. Flip numerator and denominator. I don't know if flip is a math word, but okay. So if one of the lines has, I don't know, 3/5, the other one is going to be -5/3. Okay. Up here, the slopes of parallel lines. We remember this from our systems of equation things. Slopes of parallel lines are the same. And that's what makes them parallel. They have the same rise and the same run. Okay. Shorthand, by the way, for parallel is that. Shorthand for perpendicular is that. Okay. Looks like a little slanty 11, and then the perpendicular marks. Okay. So let's use this, figure some things out. So we want to find the slope of a line that is perpendicular to this line, y equals 2x minus 4. So the first thing we need to know is, what's the slope of this one? Pretty obvious, slope is 2. So the perpendicular line, its slope is going to be the opposite reciprocal. So the opposite, we know we're going to have, and I'll just make a little note like slope perpendicular, we're going to have a negative sign. Reciprocal means we have to flip it over. So this is 2, we're going to make it 2 over 1. We flip 2 over 1 over, we get 1/2. So perpendicular line, a line that's perpendicular to y equals 2x minus 4 is y equals negative 1/2 x plus minus, doesn't really matter. Whatever number the intercept is, makes no difference. Could be 1/2 x plus 0. Okay? So that's when it's in slope-intercept form. It's pretty easy to deal with. When it's in standard form, maybe not so much, but we know how to change that into slope-intercept form. Let's do it this way, I guess. I want to get the y all by itself, so we're going to subtract 4x from both sides. That leaves me with 3y equals negative 4x plus 6. Divide everything by 3. Divide everything by 3. Divide everything by 3. I get y equals negative 4/3 x plus 2 divided by 3. Okay, and I know everybody loves to turn that into a decimal. We don't need it to be in a decimal. Remember, changing slopes to decimals doesn't really help us. This keeps us in rise over run. So the slope of this line is negative 4/3. Slope of a perpendicular line, looking for the opposite reciprocal. This one's negative, so we're going to go positive. I wouldn't write the positive down, but anyway. And then reciprocal of 4/3 is 3/4. So a line that's going to be perpendicular to this line is going to have a slope of 3/4. Okay, opposite reciprocals. Change the sign, flip it on over. Okay, all right, find the slope of a line that's parallel to the line containing these points. Okay, notice parallel. So what do we know about the slope of parallel lines? The same. So let's start by finding the slope. Let's get rid of that so you don't think it's a negative. X1, Y1, X2, Y2. Slope Y2 minus Y1 over X2 minus X1. I write it every time just because I want you to remember. 3 minus 7 over 4 minus 5. 3 minus 7 is negative 4. 4 minus 5 is negative 1. Negative 4 divided by negative 1 is just 4. Okay, so that's the slope of my line that goes through these points. The slope of a parallel line is going to be the same. Okay, so not that big a deal. Find the slope. If it's talking about parallel, we're looking at the same slope. Now here's the the money shot is the find the slope of the line that's perpendicular to the line containing the points. All right, so this time perpendicular. So we're looking for the opposite reciprocals. Okay. Let's see. We got to find the slope of this one. X1, Y1, X2, Y2. Slope y2 minus y1 over x2 minus x1 and 8. Subtract 3 over 4. Subtract 3. All right. Now 4 subtract 3. I did it. There's my mistake for the day. 4. How about 4 subtract 5? Is that better? All right. 8 minus 3. 4 minus 5. 8 minus 3 is 5. 4 minus 5 is negative 1. So my slope here is negative 5. Perpendicular, we need the opposite reciprocal. So since this slope is negative, we know the other one's going to be positive. And the reciprocal, well, we used to have 5 over 1, so let's make it 1 over 5. So if we're looking for a line that's perpendicular to the line that goes through these points, it's going to have a slope of 1/5. The intercept can be whatever it is, it's going to be perpendicular because remember lines go on forever and ever and ever. Okay, so builds on what we remember from Math 1 about slopes. Just one extra thing to remember, opposite reciprocals. Opposite reciprocals. Change the sign, flip over numerator and denominator. Change the fraction over. Okay, so for this one we're using it now, but we also use this when we're in calculus. We talk about slopes of perpendicular and parallel lines fairly extensively. So if, for instance, I had some sort of a curvy thing like that, what we tend to look at in calculus is we look at tangent lines. So we're looking for the slope of a line that just touches the curve, and in reality it only touches the curve at one point. Okay, so if we're looking for it, we can find the slope of this tangent line using what are called derivatives, and it's a whole other story. But sometimes the question will say, well, what's the equation of the normal line? And the normal line is the perpendicular. So this is what we call normal, and this is what we call tangent. And the normal line is perpendicular to the tangent line, so if I can find the slope of the tangent line, opposite reciprocal gets me the slope of the normal line. Okay, that's a little extra stuff that that we're in there for. I think that pretty much does it. I should ask you some sort of a question to make sure you actually watch this whole thing. Maybe I'll just ask you, well, what's this sound effect that we play right at the end? Okay, so thanks for watching. Come with questions tomorrow. We'll see you soon. Bye for now.